Here are some practice problems to put at the end of your 8.2 investigation. Pause the video as often as you need to draw the diagrams in your notes and to write the work to solve the problems. For this first one, I can see that it's a triangle, so you always want to start with writing down the formula. And the formula for the area of a triangle is base times height divided by 2. Then I can plug in the information that I know. I know that the area is 64. I know that the base is 8, and I don't know what the height is. This is the equation that I have left to solve, and I can show you at least 2 different ways to solve that equation. One way to solve it is to undo the divide by 2 by multiplying both sides by 2. Then we get 128 equals 8h. And we can divide both sides by 8 to get that the height is 16. We always want to put a label on our answer, so the height is 16 feet. Now another way to get that same answer is to simplify before we start doing things to both sides. 8 divided by 2 reduces to just 4. So another way to get that same answer would be to change it into 64 equals 4h. Then we just need to divide both sides by 4, and we still get that the height is 16. So there's more than one way to solve that problem. The second shape is a kite, and we know that the area of the kite is diagonal 1 times diagonal 2 divided by 2. The first diagonal is 2 plus 2, or 4 centimeters long. The second diagonal is 8 plus 2, or 10 centimeters long. So the area is 40 divided by 2, or 20 centimeters squared. Number 3 is another problem where we need to work backwards. We know what the area is, and we're going to solve for the variable. It's always a good idea on these problems to start with writing down the area formula. The area formula for a trapezoid is base 1 plus base 2 times the height divided by 2. Then we can plug in the values that we know. The area is 126, the bases are 16 and b, and the height is 9. There's more than one right way to solve this problem, but probably the easiest is to start by undoing a divide by 2 by multiplying both sides by 2. That way the multiply by 2 and the divide by 2 cancel out, and we get 252 equals 16 plus b times 9. And there are still multiple ways to go from here. Usually what most people choose to do is distribute the 9 to both parts and do 9 times 16 plus 9 times b, and then solve the equation from there. So if I want to get b by itself, I need to start with subtracting 144 from both sides. And then to undo the multiply by 9, I need to divide both sides by 9. And I get that b is 12. Looking back at the units, it'll be 12 inches. In this shape, they're telling us that AB is 6, AC is 8, and BC, the entire side, is 10. We're supposed to figure out the length of AD. Since this unit is about area, there's a hint that we're probably going to use area somehow. And the way we're going to do it is figure out the area of this triangle in 2 different ways. One way, using the base and the height of 6 and 8. those two are a base and a height because they meet at a right angle. So I can figure out the green area of this triangle by doing base times height divided by 2, or 6 times 8 divided by 2, which equals 24. But there's another way to figure out the area of the same triangle by sort of turning it on its head. We can also think of this side as a base and this as a height because those two meet at a right angle. So another way to get the area of the exact same triangle using a different base times height would be to do 10 times x divided by 2. 10 divided by 2 we could reduce to 5x. Since that was two different ways of finding the area of the exact same triangle, those two things should be equal to each other. So I can write an equation that says 24 equals 5x. And now I'll be able to solve it for x and figure out the length of AD. The length of AD is not a very nice number. You can leave it as a fraction, 24 over 5, or you can change it to a decimal, and that decimal would be 4.8. The units in this problem are centimeters. To find the area of the shaded region in this next problem, we're going to figure out the area of the big trapezoid, and I know it's a trapezoid because it does have one pair of parallel sides. I'm going to figure out the area of that big trapezoid, and then I'm going to subtract off the area of the white triangle that's missing. So the area of the big trapezoid, I know that the area formula for a trapezoid is base 1 plus base 2 times height divided by 2. So in this case, the area is going to be 20 plus 12 times 4 divided by 2. 20 plus 12 is 32 times 4 divided by 2 is 128 divided by 2, or 64 centimeters squared. That's the area of the entire trapezoid. To find the area of the triangle, I need to do base times height, and the height is still 4. So if I do base times height divided by 2 to find the area of that triangle, I'm doing 12 times 4 divided by 2, or 48 divided by 2, which is 24 centimeters squared. That means if I just want the area of the shaded region, I need to take the area that I got for the big red trapezoid and subtract the area that I got for the white triangle and get that the area of the shaded part is 40 square centimeters. On the last example on this page, it says that TP is tangent to circles M and N. If it's tangent, that means it makes 90-degree angles. Since those two are both 90-degree angles, that means that this side is parallel to that side. Then we're told that TP is 16, the radius of circle N is 7, and the radius of M is 4. We're supposed to figure out the area of the shape that goes from N to M to P to T. Because that shape has one pair of parallel sides, that shape is a trapezoid. And I know that the area formula for a trapezoid is base plus base times height divided by 2. The bases are the two sides that are parallel, so the bases are 7 and 4. And because of our right angles, the 16 is a height. 7 plus 4 is 11 times 16 divided by 2 11 times 16 is 176. And if we divide that by 2, we get an area of 88 centimeters squared. I'd like you to try to figure out the area of these 9 figures on your own. Pause the video and figure out all 9 on your own, then restart the video and compare your answers. Compare your answers to the answers that I have for 1, 2, and 3. Four, 5, and 6 are really more of challenge problems. If you didn't understand 4, 5, and 6 and you weren't able to figure them out, that's okay for right now. And the main reason that that's okay is because to figure out number 4 and number 6, you need to know the Pythagorean theorem. That is something that you have probably learned before, but you may not remember it. We will cover it later in geometry. So if you couldn't figure out 4 and 6, that's okay. Number 5, I think, is very important to understand, though, because it gives us an alternate formula for the area of a trapezoid. That is a mid-segment because it goes from midpoint to midpoint. And if you remember from a previous chapter, how we find the mid-segment is add up the bases and divide by 2. Well, that exact thing is in the area formula for a trapezoid. Add up the bases, divide by 2. So an alternate formula for the area of a trapezoid, another formula that also works, is just doing the mid-segment times the height. That's a formula that is important that you should add to your green conjecture sheet. Area of a trapezoid is mid-segment times height. So the area of this trapezoid is 216 square meters. The last 3 were pretty straightforward. All of them are parallelograms, so you can figure out the area of each one using base times height. Compare your answers for those 3.